Okay, guys, morning or afternoon, depending on when you're watching this. So we're going to look at waves, and the part of your revision I'm going to look at is P6 waves. We're going to look at what a wave is and what's the difference between a transverse and a longitudinal wave. So if your trilogy and your revision guide is page 218, you might have a different revision guide. Okay, now we're going to start with some basics to do with waves. What I've got here is a little system. So a group of objects that you study in the specification. They've got a system, and I can make a wave in it. Look, I've got beads on a string. Okay, I can change the end to make it no end like that, and I can send like a pulse along the beads on a string. Now these beads represent particles. In this case, like plastic beads, I guess, but they could be any sort of particle you like. It's the general principle we're looking at, and I can send the pulse along. So first thing, what is a wave? Watch the particles. If I go like that, I'm giving the particles energy, kinetic energy. They're moving, okay? And the energy has gone from the beads moving up this end where my mouse is. The energy goes along the wave, along the beads, and ends up going out the window there. So when the wave has gone past, when the beads have stopped again, the energy has transferred from here, where my mouse is, to wherever the wave ends up. But look, the particles are back in the same place. Okay, the particles moved when the wave was going past, but they end up back in the same place, whereas the energy has gone from here over to here somewhere. So waves transfer energy, but they don't transfer matter. The beads are back along there. If I was to throw a tennis ball, I've transferred energy into the tennis ball, and the tennis ball has moved as well. The tennis ball has gone somewhere else to where I've thrown it to. Throwing a tennis ball transfers energy and matter. A wave transfers energy but not matter. Look, the particles are back where they started. Okay, right, fantastic. Right, now I can make this a regular wave like that. I can make it oscillate. The particles go up and down. And there's a few words here that we have to understand. So if you look, waves going from left to right, going out the window, transferring that energy, and I can change some of these, some of the settings on this wave. So let's have a little look. This word here, frequency, and it says Hz next to it. The Hz stands for hertz. Okay, I can turn up the frequency. The frequency number's getting higher. Now, what's happened to the wave? Well, if you were to count the waves going past, there are more waves going past every second. Okay, and that's what the frequency is. It's the number of waves going past a point every second. So look, that's a low frequency. But if I put my mouse here in a point that so half a wave, one wave gone past. A wave is once up and once down in this system. If I turn the frequency up, there's more waves. If I put my mouse pointer there, every time a peak goes past and then another peak, that's a whole wave. There's more waves going past every second. So the waves, the frequency, it's a number of waves every second, and it's measured in hertz. Right, let's put the frequency back in the middle somewhere. Okay. Now, what I'm going to do now is I'm going to change this word here. This is the amplitude. Right, watch what happens to the wave when I change the amplitude. Look at what's happened to this piston. It's going up further and down further, up further and down further. I'll make it smaller. I'm not going up and down as far. So the amplitude is the displacement from this middle line, this dotted line, is how far the wave displaces up or how far the wave displaces back down again. Okay, and the two things are independent. I can have a really big amplitude and a really low frequency. Okay, or I could have a really small amplitude and a really high frequency. Okay, they're independent of each other. When you're drawing them, it's tempting to make a wave with a big amplitude, a higher frequency. You know, something about human nature that makes us to do that. They're independent. Okay, so let's have a little look in our revision guide. So here's my wave, and let's have a little look at the names of the parts of the wave. So here's my wave. Look, it goes up once, down once, and back to the start. That's one wave. One up and one down is one whole wave. So on the screen there, you've got 1, 2 waves. Okay, the height, the distance from the middle line, the still point in the middle, to the crest of the wave is called the amplitude. That's the same distance as the middle to the trough of the wave. It's the same. If you measured it with a ruler, it's the same distance. So the amplitude is from the middle to the crest or from the middle to the trough. Sometimes in the exam question, they label a wave like this, and they give you some letters for different things. And sometimes, to distract you, they say one of the options is to make the amplitude from this point right down to the trough. That whole thing is not. It's from the middle to the crest, or the middle to the bottom. The wavelength is the length of one wave. Okay, so look, once up, once down, that's the wavelength. It's the same distance if you did it from the crest to the crest, or from the trough to the trough, as they've done here. It's the same. They're all the wavelength. Okay, and then the number of waves every second is the frequency. So look, I've got 2 waves on my screen there. If that had gone, this little dot here, the wave, if that had gone past in 1 second, that'd be 2 waves in 1 second. So the frequency would be 2 hertz. Okay, so that's your wave basics. Now, there are 2 different sorts of wave that you can have. One is called transverse, and one is called longitudinal. And you have to be able to really clearly say what a transverse wave is and what a longitudinal wave is. And it can be quite a mouthful. The best way of doing it is talking about the particles in the wave. Okay, what direction is the wave going in, and what direction are the particles going in? I'll give you an example of a transverse wave. You've ever been in or seen a Mexican wave? If you imagine yourself in a football stadium, you're looking at or it can be any stadium, a sports stadium, you're looking at the crowd. So you're in the middle of the pitch looking at the crowd. You see the crowd all sat down. They decide to do a Mexican wave. And the people doing the Mexican wave, when you do a Mexican wave, you go up and down. As the wave comes, you stand up and sit down. Okay, so you're going up and down, but looking at it, the wave will be going along. If I show you on my screen that, screen's taking ages. Here we go. So what happens? This is the person. The person would stand up, and they'd sit down, and then the person next to them would stand up, and then they'd sit down, and the person next to them would stand up, and then they'd sit down. They do it in that order. So they are going up and down, but if you were looking at it, the wave would be going along like that, and it would go from here, then it'd be there, then it'd be there, then it'd be there, then it'd be there, and these people would be going up and sitting down as these guys are just sat there. Okay, it's transferred energy. The energy's now here, but the people, the matter, are back at the start. Okay, that's a transverse wave. The wave is going in one direction as the particles are going perpendicular to that direction at right angles, going up and down as the wave goes along. Okay, it's a transverse wave. A good example of that is a water wave. So let's have a quick look on this simulation. If we look at water wave, I'll look from the side. So what we've got here is a tap, and here's some water. We've got to look at our words frequency, the number of waves every second. We've got our amplitude here. So if I drip the tap, look, boink, boink. Right, and I'll pause it. Look, the drip of water is going down and then up, down and up. The water particles are going down and up, but the wave is going from left to right. That's a transverse wave. Okay, imagine I put a duck floating on the water. The duck might get pushed along a little bit by the wave, but basically the duck would be going up and down. It'd be bobbing up and down. If you've been in the sea or been in the wave machine, you bob up and down. Yes, it does, probably because of friction, it does push you along a little bit as well. But the duck would be going up and down as the wave goes from left to right. That is a transverse wave. Okay, your teacher, when he or she showed you a transverse wave, would have used a slinky spring on these things, and they would stretch the slinky spring across the desk, and they'd wobble the slinky spring from side to side, so the wave would go along, but it would make an S shape, which is the transverse wave. So let's have a look. It's a transverse wave. The particles going up and down as the wave goes along. Okay, so what's going to happen to the dripping if I turn the frequency up? Okay, let's have a look. I turn the frequency up. Look, drips more times every second. So it's a higher frequency. That's a higher frequency wave. If I turn the frequency down, the dripping is less times every second. You have less waves every second. It's a low frequency in hertz. Number of waves every second is frequency. What about the amplitude? Let's take let's turn the amplitude down. Well, look, how the distance from the flat water to the crest, or the flat water to the trough, is less. It's a lower frequency. Look, big amplitude. Oh, look, Look at that. Look at the distance between where the water's flat and the crest or the trough. Big. So look, that's the biggest wave. Look, have a look. That's the biggest amplitude, highest frequency. There you go. They're independent of each other. So that's a longitudinal wave. Just remember what the definition of a longitudinal wave is. The particles are going in one direction. So wave goes at right angles. Look, that there is a right angle or perpendicular, as we sometimes say. So that's a transverse wave. Right, the next sort of wave you need to know about is a longitudinal wave. Now, we said a transverse wave, okay, the particles are going perpendicular to the way the wave's going. In a longitudinal wave, the particles will be going in one direction and the wave will be going in the same direction. Okay, so let's look back at our example of a slinky spring. Look here, the teacher will have laid the slinky spring out across the desk and will have moved their hands backwards and forwards and sent like a pulse along the slinky spring. So the coils of the slinky spring are going like that, and the wave is going along in the same direction the coils are moving. And what you end up seeing is like this little compressed bit pulsing along the spring, and that's a longitudinal wave. The particles are going in the same direction, like here, the same direction that the wave is going. Transverse wave, the particles are going at right angles to the way the wave is going. Longitudinal waves are going in the same direction. That's all you need to say. People get tongue-tied in the exam, but just what direction are the particles going in and what direction is the wave going in? If it's the same direction, it's longitudinal. If it's at right angles, it's transverse. For transverse, think Mexican waves. The people are going up and down, the waves going along. Okay, so when you do your slinky spring like this, these little compressions where the coils have compressed up, going the same direction, okay, they're called compressions, and where the slinky spring is stretched out, that's called a rarefaction. Okay, let's have a little look at an example of a longitudinal wave. This is a little bit harder to see, than the water wave, but let's do it anyway. These are air particles, the little white and red dots, okay? And here's a speaker, right? This speaker's got a cone and it moves backwards and forwards like that, and it makes the air vibrate. And that vibrating air goes into your eardrum, makes your eardrum vibrate, and sends a signal to your brain, and you hear a sound. That's how hearing works. So let's turn the sound on. You can probably hear that, the sound. Turn it off. Right. Look at the way the speaker cone's going. It's going left to right, look, in and out that way. See my mouse, look, going backwards, in and out like that. Look at the way the individual air particles are moving. They're going left to right. And the wave has gone from where the speaker cone was, spread over to this side. So if you had your ear here, you'd be able to, you'd hear a sound. Okay, so look. Oh, I've stopped it. Let's turn the frequency up. If I turn the frequency up, oh, that's why I pressed that green button. Look, the speaker cone will go backwards and forwards more times every second. The air particles will go backwards and forwards more times every second, but they're going in the same direction. The speaker cone's going like that. The air particles, it's pushing the air particles, making the air particles go like that. Same direction, it's a longitudinal wave. Look, I can turn the frequency right up, and the speaker cone will go faster, air particles go faster. That would be a higher pitch sound. Turn the frequency down, the speaker cone goes slower, less frequent backwards and forwards. The air particles going less frequently backwards and forwards. It's a lower sound, lower pitch sound. Okay, let's turn that off because that's annoying. So that is a longitudinal wave. Okay, the particles are going in the same direction. If we see it on the screen, but here's my sort of speaker cone. My speaker cone was vibrating backwards and forwards like that, and it was making the air particles go backwards and forwards like that, and that would knock into that one, and go that way. That would knock into that one, pull it back, and get that movement like that. And if your eardrum is over here, your eardrum is just a little flap of skin, the air particles would knock into that and then make your eardrum go backwards and forwards like that. And that would go off to your brain through a nerve, and you'd hear a sound, and your brain would interpret it as a sound. Okay, that's a longitudinal wave. Okay, so some examples of transverse waves, you've got water. I remember water waves. Example of a longitudinal wave, remember sound. They're the ones that come up all the time. Okay, so quick recap. Waves. Waves transfer energy, but not matter. You've got to know what frequency, amplitude, and wavelength are and identify them on a diagram. Amplitude is from the middle point, the resting position, to the crest, or from the middle point to the trough. It's not that right from the top to the bottom. Wavelength, length of one wave, you can go peak to peak, trough to trough, middle to middle. Okay, you know the frequency is the number of waves every second that we measure in hertz. Okay, we've got two sorts of wave, transverse and longitudinal, and you have to be able to put into words what a transverse wave is and a longitudinal wave is. And you talk about the way the particles are vibrating compared to the way the wave is moving. If it's going in the same direction, that's longitudinal. If it's at right angles, if it's perpendicular or right angles, they mean the same thing, then it's a transverse wave. Okay, right, I hope that was useful. Thank you for listening, and it's all there in your revision guide. Just check.